If I tell you, go write a new database that is better than everything existing, you will probably not do it. Actually, I did not want to implement ClickHouse because it sounded insane. Sometimes I'm thinking about some problem and I see that I know exactly how I should do it. I want to do it right now at 3 a.m. on Saturday. And then I just go and do it.
Welcome to Data Talks on the Rocks. I'm Mike Driscoll. Most database founders will tell you that their tech is fast. Alexey Milovidov will tell you that ClickHouse is the only one that works, and then prove it. It's a bold claim. But when you're processing petabytes a day, powering real-time AI applications, and replacing whole categories of specialized databases with one all-purpose engine, bold might just be accurate. In this episode, we explore what happens when a mathematician who thinks in probability distributions builds an analytical database. We get into why simplicity beats complexity, how ClickHouse is overtaking time series and observability platforms, and why, after 15 years after creating ClickHouse, Alexey is still up at 3 a.m. on a Saturday writing code. Not to fix bugs, but because he can't wait to solve the next problem. Let's get started. So we're going to talk about ClickHouse. The database ecosystem is an incredibly crowded space. In the last few years, we've seen lots of new entrants. And despite that crowd, ClickHouse has emerged as one of the fastest growing and most popular database technologies in the world. I want to start and just start by saying what I know about ClickHouse. Obviously, and what many people know about ClickHouse is that it is insanely fast. But before we dive into the architecture and go a little deeper on that, I really want to understand from your perspective why you believe ClickHouse is so popular. Why are developers choosing it? And I want to frame this discussion from the perspective of people who are out there today, might be listening to this interview, might be searching the web, and they're an engineering leader, they're a developer, and they need to choose a new database to power a new initiative, or they need to migrate from an existing database that's not scaling, that's not meeting their needs. What are some of the pain points that ClickHouse uniquely solves, which are not being solved, in your view, by other databases, other technologies on the market, like Snowflake or Postgres?
Mm-hmm. There are some scenarios when ClickHouse is the only working technology, the only working analytical database. You take any other alternative, like Snowflake, and it does not work for low latency queries. You cannot use it as a backend for real-time application to serve user requests directly. You take BigQuery and it also does not work. It can handle large data volumes, but not in interactive fashion. You take Redshift and it also does not work in real time. It does not provide all the features of ClickHouse. It does not have such attention to details. If you take Postgres, it is just not an analytical database. There are a few modules for Postgres, but they are far away, far behind the quality that is actually required. You take some other technology like Vertica, and you will find that it is a long time ago in a private equity, and they will just squeeze all money of you, and the quality is also far behind. So ClickHouse is actually the most popular open source analytical database as of today, and I really like it.
It seems to me, as an observer, that more and more AI companies have been adopting ClickHouse for what feel like different use cases. They don't seem like they're all the same. So maybe you can just share with us, what are you seeing? What are some of the features in ClickHouse that are making it widely adopted by folks like Weights and Biases and others out there?
Mhm. There are many scenarios. One is about what you do to prepare your data to train a machine learning or AI model. If you are old-fashioned, you will say machine learning. If you are hip, you will say AI. And this includes the scenario of feature stores. So you collect a lot of data, I don't know, you track your users for advertisement. It's a boring and maybe hated use case, but it exists. You collect this data, and for your model, you have to organize this data into high-quality features. And this process of data preparation, data summaries, aggregation, and even data profiling, this is solved by ClickHouse. Another scenario is ML ops and ML observability. It means how to make the process of machine learning don't be messy and chaotic, how to organize this process. And this is what companies like LangChain, weights and biases use ClickHouse for.
BrainForge is another one, I think.
Brain trust.
Brain trust, yes.
Yeah. And another scenario is semantic search and analytics on embeddings. So vector embeddings is a way to transform multimodal data, images, text, videos into something that is suitable for search and analytics, multidimensional vectors. And you can run some queries that will extract a subset of these vectors, search for similar ones, aggregate, summarize to provide recommendations. And many companies are also using ClickHouse for this scenario, especially when this amount of vectors is just massive and cannot be indexed in advance when it cannot fit in memory. In these cases, many specialized vector databases stop working and ClickHouse continue to work. But we still have a lot of work to do to optimize vector indexes. We still have to introduce some vector indexes that we don't actually have. We want to better serve this use case.
So just to repeat that back, it sounds like there's 3 different use cases inside of AI that ClickHouse seems to shine at. One is feature stores, which sounds a lot like just a database with a fancier name.
Preparation, data science, data profiling, data cleaning.
And then the second is just telemetry, observability.
Yeah.
Coming off of the training of these models.
Not only training, also inference.
Okay.
Yeah, from inference, you have a lot of logs you have to analyze.
I see. And then the third is what some would consider, or in some cases, you have companies like Pinecone and several others, vector search, vector embeddings. Okay. That's
Yeah. And you don't have to limit yourself just for a single scenario of vector search. It is much more. You search across metadata of your data. You do not only search, but also analytics. And you take the results, you put these results as a context to LLM, and you will get something interesting out of this.
Does ClickHouse have a native data type for vector embeddings?
Yeah, and what is interesting, we used to have this data type from 2012.
What was the motivation for that when it was built? Was it to support a search use case?
No, it was not related to AI at all. It was related just to collect some identifiers, categories into an array. And for vector search, we just use this array data type with floating point data type. That's
interesting. You shared last night, it's been, of course, a long time in the making, that there is a new data type that ClickHouse supports, a JSON data type natively. Clearly, when it comes to observability and the data exhaust coming off of many systems, JSON is the lingua franca for how most systems, emit data. So, no surprise that the AI companies are also generating a lot of JSON logs that need to be made sense of. Beyond speed, beyond performance, which again is really top of mind for everyone who thinks about ClickHouse, is it's so fast. What are some of the other aspects that you think differentiate ClickHouse? Cost efficiency, the open source license, developer ergonomics. What are in your opinion, as the lead author of this project, what do you see developers responding to, and when compared against other tools?
Mhm. The feature set, and it comes from the practice. So for many use cases, it feels really natural when you see these features in ClickHouse. Like if you do clickstream analytics, web analytics, or if you do telemetry, you will find functions and functionality exactly for this. Like when you just read the documentation from start to end, you will notice there are probably 5 or even more functions just to calculate quantile.
Mhm.
But there is a reason for that. And people uh, who make these applications will find that this is made exactly for them. And the same in other areas. I was surprised when uh, to see many blockchain analytics applications, and they say these data types like uint 256, they are exactly designed like for Ethereum. Actually, we designed them for other use cases, but they fit they fit very natural.
Yes. We'll talk a bit about some of those features in a bit. I now want to go down a level and talk a little bit about the ClickHouse architecture. Nothing is ever built from scratch, right? Nothing ever arrives in this world sui generis. What were some of the other technologies that inspired the design, the architecture, the choices behind ClickHouse? What other databases had you had experience using, or did you study in your earlier experiences or your educational experiences? And then were there any contrarian choices that you made with regard to ClickHouse where, you decided to go against some of the conventions that other database tools had chosen? Um, yeah, so tell us about what were some of the precedents that led you to design ClickHouse the way you did?
Mhm. I started working on ClickHouse in 2009 for one particular challenging task, for one particular large workload, web analytics. And actually, I did not want to implement ClickHouse. Because it sounded insane. Let me, if I tell you, like, go write a new database that is better than everything existing, you will probably not do it. But I researched the area which comparable technologies existed, and I can name all of them.
This is an educate the audience question for those who are not as deeply versed in columnar, MPP database architectures. I'd like to talk a little bit about database categories, recognizing, of course, that no database fits into any one category. Broadly, we have categories like OLAP databases, Druid, Pinot, DuckDB. ClickHouse might find itself in that category. We have OLTP systems. We have time series databases like Prometheus, document stores like MongoDB, um, Elasticsearch. Where where do you position ClickHouse amongst all these different axes today? Where would you say that ClickHouse lands? And then to the extent that it overlaps with some of these other categories, what are some of those categories that it might overlap into?
Mhm. I like your classification because I also like to collect different categories of databases. We can also talk about graph databases,
Sure,
about XML. Do you remember XML
sure.
databases?
They're
So,
awful.
yeah,
Vector, or modern today, the newest flavor is vector
yeah,
databases, right?
streaming databases, whatever, a lot of kind of things. And ClickHouse is OLAP, or let's put it simply, analytical database. So the main difference between transactional and analytical databases is that with analytical databases, you take a large volume or large subset of data and summarize it in as fast as possible, as quick as possible.
Now, uh, you put ClickHouse in the OLAP category. Clearly, that's where a lot of people see it, but yet last night I saw you present and talk about a drop-in replacement for Prometheus in ClickHouse. So clearly what we're seeing when you talk about observability is there's traditionally a lot of observability platforms have used time series databases under the hood. But lately, we've also seen a lot of observability platforms starting to adopt ClickHouse under the hood. I think Sentry is a company out there that uses ClickHouse. PostHog is another. So we've seen a lot of different companies now embedding ClickHouse, using it like a time series database. Where do you see the differences and what do you see the similarities between ClickHouse as an OLAP engine and something like Prometheus as a time series database?
It's interesting. Some people notice how well ClickHouse works in the scenario of time series data, and they mistakenly name ClickHouse as a time series database. And I have to correct, ClickHouse is much more. The area of possible applications is much wider. So time series databases are suited just for a very narrow use case. When you have time and some metrics, that's it. And honestly, you don't need time series databases because this use case, as we prove, can be covered by a good analytical database.
Where do time series databases break down? Clearly, these time series databases that use tags and have a single time series per metric get very expensive as companies scale up. Why is that, and where do you think ClickHouse in particular, or maybe OLAP engines in general, are a better alternative to a time series database with, maybe I'll just say, high cardinality data where you've got a lot of different categories of metrics?
With this type of data, you don't have to limit yourself just to this data model. You might imagine you could specialize your data structures, but actually you have to get fundamentals right, and fundamentals like data compression, query engine, how data is actually sorted on disk, what is the storage. And if you get it right, you can solve this, and probably more efficient if you compare it to when you just focus on a single data model. And to your question, why Datadog is so expensive? Because they are greedy.
That's that may be a reasonable. One could argue that the market supports the price, and so they're charging a fair price. Let's talk about other OLAP data engines, and rather than criticizing them, one thing I want to do is turn this question on its head. A lot of people we talked to when we started, just chatting today, we talked about the framing of an engineering leader, a developer who needs to make a decision for what's a fast analytical database that I want to choose. And right now, if you look out there, a lot of people are looking at Apache Druid, Apache Pinot, DuckDB. There's some new contenders out there. There's always new folks showing up. Rather than talking about what you may, as the author of ClickHouse, not like about those OLAP engines, I'd like to hear, to the extent that you do, I'd like to hear what you admire about those different OLAP engines, and maybe if there's anything you've learned from them or anything you may consider building ClickHouse towards in the future.
First of all, don't worry. I like every database technology. Every database is interesting in its own regard. So let's talk about, say, Druid. I remember when Druid was named Meta Markets Druid. And first I learned about it when I found a really good article about the application of hyperlog algorithm. Do you know it?
I mean, of course, that I was at the company that created Druid. I was the CTO at Meta Markets, and I pushed very hard for us to adopt hyperlog inside of Druid because it was being used at Facebook at the time. Facebook had an implementation of hyperlog, right, for approximate counting. So Absolutely. I was very fond of that algorithm in that blog post for sure.
And there are many technologies that I would say their authors thought that you should have do something really complex to solve analytics. And the examples are multidimensional OLAP, when you aggregate data by every required dimension. But in contrast, ClickHouse is trying to approach this in a simple way, maybe in a brute force way. Don't aggregate anything. If you want, you could do it in ClickHouse, but by default, just imagine it is like a relational database with flat tables and calculate everything on the fly. And surprisingly, it works. And if you compare to Druid or other technologies like Apache Kudu, Apache Kylin, there are
Kylan, right?
Kylin.
Yeah. Yep.
There are so many Apache technologies. it is easy
It's a zoo.
easy to get lost in them. They try to stick together multiple components. One will be responsible for data ingestion, another for aggregation, yet another for something else. And you will have to write complex JSON or YAML configurations just to get data into the database. I don't like it because if I start reading the documentation about, let's say, Apache Kudu, it starts to be boring from the first paragraph.
So I'm gonna shift forward, which is and talk about that. You mentioned getting tired of reading long documentation, and I think you were referring to some of the other database technologies out there are quite complex. You have to manage a number of different different instance types in your cluster topology just to make it work. One of the things that I personally admired about ClickHouse is the developer experience that, as you said, there's actually not a lot of different types of instances involved in ingestion in a different instance and involved in joining up subqueries. Getting started with ClickHouse is very easy. Using ClickHouse in general feels good. And so I guess I'm wondering, what are some of the principles that have informed that developer experience, those design choices? If you were to state, when you think about introducing a new feature like a JSON data type or introducing support for Kafka, consuming Kafka streams, or being able to automatically ingest data off an S3 bucket, right? A few of the things you talked about last night. How do you make sure that those features don't end up having a wall of documentation that you have to scroll through just to get them to work?
Actually, we ensure that we do have documentation for all of these features. But I think the main reason is that I am a ClickHouse user, and I am a really bad user. I notice when anything just is slightly not right. When I go to production, I open the logs, and I always notice that something has to be improved just slightly. When I open our website, I see something like, if my display is not high DPI, the gradient does not look correct. And I report this. And this is not about technology, it is just about attention to details. But the same thing applies when you install and start using ClickHouse. Actually, you even don't have to install it. You just download and run it. And that's the magic. And when a command line application opens, I ensure that there is nothing strange for me. But also, I think about all of our users.
It's very common that people say that great products are built by folks who are building those products for themselves. So clearly, this is an example of that. You're using the product every day. I've seen you on the train from on our way from Brussels to Amsterdam. So clearly, you have a deep connection with your own product and technology that informs some of this design taste. I want to shift a little bit and talk about something that you've been asked in previous interviews, and that is, and I've asked you even privately about, which is that there's a vibrant community of open source users that are part of the ClickHouse, part of the ClickHouse ecosystem. I think you again mentioned over 2,000 contributors to the project. On the other hand, you are now the co-founder of a company, a commercial company that's raised hundreds of millions of dollars, and you have customers that are out there demanding new features, new things. How do you balance the demands of that vocal open source community that in many ways helped get ClickHouse to where it is today against the needs of commercial customers who may have a different set of needs, desires, roadmap requests? How do you, as the author, the largest contributor to ClickHouse, make sense of these contending, potentially at times not consistent set of requests?
Mm-hmm. But I would say these requests are mostly the same for open source and for commercial users. And when they are not the same, I'm trying to slightly generalize to think more about these ideas. And maybe I will implement some feature set, some functionality inside ClickHouse that will automatically serve both type of the audience. But we have the principle, yes, customer first. If something is needed for our customers, we will do it.
Alexey, tell us, what is the biggest difference between open source ClickHouse and ClickHouse Cloud?
The table engine. ClickHouse Cloud has a different table engine that is developed to allow scaling, dynamic scaling, changing the number of nodes quickly. So this makes it possible first to run our service for many thousands of customers, and second to make these customers make them not plan in advance their usage. And for open source customers, we have very interesting scenarios. But for many of these scenarios, it is enough to just provision a couple of machines, a couple of replicas, run ClickHouse, and problem solved. Some of these scenarios require like loading several petabytes of data a day. Then they have to actually think about their infrastructure because it will cost some round numbers. But ClickHouse scales for this workload, both the open source and the cloud version of ClickHouse. So it is really nice.
I want to talk about ClickHouse past, present, future. We've talked a little bit about some of the inspiration that you had for the architecture of ClickHouse. Have there been any significant pivots or changes in the architecture of the ClickHouse project since its inception? And maybe another way to say is there anything that you thought you had right when you were first designing ClickHouse and later learned through the real world experiences that you need to change? And what were the pressures that drove those changes?
Mm-hmm. I remember 10 years ago, in 2014, ClickHouse was just started to be used in production, and there were no replication. And we start thinking how to get a replication into ClickHouse. And my colleagues, who were Java engineers, suggested me to use ZooKeeper. Like, unit distributed coordination.
I knew you were going to say ZooKeeper, but I intentionally didn't push you.
Unit distributed system, there should be ZooKeeper. Mm-hmm. And this decision was quite unnatural for me, but I accepted it. And we started use ZooKeeper for metadata. But 2 years ago, We rewritten ZooKeeper with our own implementation, ClickHouseKeeper, which is, by the way, compatible on the wire protocol level. So the API is the same, everything is the same, but it is written in C++. It is more memory efficient.
That's great. I think you're, of course, not the only open source project out there to refactor ZooKeeper out of its project. Mm-hmm. Last night at Cloudflare, you mentioned the analyzer and talked a little bit about the 2-year journey to get from alpha to beta to now being standard with every ClickHouse cluster that's launched in ClickHouse Cloud and available for all. Tell us a little bit about why that took 2 years to build, and maybe more importantly, what do you see as the payoff to users of ClickHouse? What's possible now that wasn't before, now that the analyzer exists?
So let me explain. Analyzer is the infrastructure for query analysis and query planning and query optimization. And many people ask me, why did you have to implement it? There are some open source projects for query analysis, such as Apache Calcite. It is written in Java, but there are databases written in C++ that somehow plug in this Java project. Or there is Apache Substrate and Data Fusion. There is some project from Greenplum also for query analysis. Why did not I just take them? The reason is that ClickHouse has a lot of convenient and good features. It is a SQL database, but it is SQL. Its SQL language contains a lot of extensions. For example, you can write aliases, names, for expressions in any part of other expression. There are extensions such as array join and lambda functions, higher order functions. When SQL starts to feel like a functional, actually SQL is a declarative programming language, but here it starts to feel like maybe like Haskell. Some people like it. It is not as complex as Haskell. And we did not want to lose it. But we had to support all the corner cases. And the most importantly, we have to do it in 100% compatible manner. We don't want to make it like Python 2, Python 3, when there are subtle incompatibilities and migration takes 10 years. So we want to make it in a way that we just switch, enable it by default, and the user will only get the advantages: better performance, more features that were not available before, and no incompatibilities. And for features, actually, there are many such features like recursive CTE. When we enabled Analyzer, it was just a few days change. It was easy.
What are some of the real world use cases that you think the analyzer will have the biggest impact on, just from your experience talking to users of ClickHouse out there?
I think data warehousing use cases. So we discussed real-time analytics, analytical applications, but also there is something I would say classic data warehousing. When you collect a lot of information about your company, about some artifacts producing by your company, and you join this for business analytics. The problem in this use case compared to applications is that these queries are written, they are ad hoc queries written by users, or even worse, generated by business intelligence systems.
Not mine, but others maybe.
Yeah. And these queries are huge. They contain a lot of subqueries, joins, correlated subqueries. And the database system has to deal with all this mess. It has to optimize, it has to rewrite these queries. And our abilities to analyze and rewrite queries were quite limited before Analyzer.
So, for instance, Tableau or Looker, which generate, if I've ever inspected the SQL that's generated by those tools, it can be quite verbose. you're saying that now ClickHouse is perhaps better suited to handling some of the queries that are generated by those tools in the same way that other databases like Oracle or Snowflake or BigQuery, Redshift, they have their own analyzers that are maybe taking some of that verbose queries and doing some optimization on it to make it work.
Mhm. When you say about these business intelligence systems, I would make a line and put Rill to the far end of this line. In between, there will be Tableau, Looker, and somewhere at the back, there will be MicroStrategy or what else?
Uh, you know, very old tools,
Mhm.
right? MicroStrategy, maybe you go back, and think about the history of BI. There's some very old tools out
Yeah,
there.
they even look old. So Rill already works perfectly with ClickHouse. Tableau has a native connector with ClickHouse, but the main point, every system has to work, even such old tools.
We're talking about past, present, future, and we talked about the analyzer. Okay, so to your journey, much like your decision to rewrite rewrite ZooKeeper out of ClickHouse and create ClickHouseKeeper. Obviously, a Java, you could have done the same thing with your analyzer approach and taken Apache Calcite, but a lot of advantages to leveraging something that was built natively to work inside of ClickHouse and take advantage of the unique extensions to SQL that ClickHouse has built. What do you see as a similarly thorny kind of long range problem with high impact like the analyzer that you're excited to tackle in the future with ClickHouse?
First, let's talk about the product and our customers. So when we just introduced our product, the first customers were like, let me imagine, a blockchain company from Hong Kong. Now there are more companies like, again, let me imagine, a bank from Germany. And we will have more and more such customers. And the main challenge is to make our product good for these large customers. We don't even had every requested feature in our product. For example, it started with AWS support. Then we introduced GCP in half a year. Then Azure. Just a few weeks ago, we introduced a BYOC solution. And I hope
bring your own cloud for those who are not familiar with BYOC,
Yeah.
because C could stand for ClickHouse too.
Mhm.
So, but BYOC is they can bring, much like Databricks, they can bring their own they can bring their own VPC, or they can bring their their own cloud environment, and ClickHouse Cloud will run within that environment.
Now let's imagine there is some old telecommunications company and they say we will not use any sort of a cloud anytime, but we want to use ClickHouse and we want to use your product with the scalability that you provide. We want to use your engine. We want to use security features and everything, and we should make our product good even for this type of customers.
So just to follow that, though, we've talked about BYOC bringing ClickHouse Cloud into a major bank or a pharmaceutical company or automotive companies, their cloud environment. But now you're talking about the possibility of bringing ClickHouse and some of the features of ClickHouse Cloud into an on-prem environment.
It's just one of the possibilities. Why not? And why don't bring the full feature set of our product to this type of customers?
Do you see a real market there of customers that has still not adopted, kind of the traditional cloud vendors for their compute workloads?
There is definitely is, but what is more interesting, let's take a large conservative company, and you approach this company, ask if they use ClickHouse, and they say probably not. But after a while, you discover that some of their engineers already installed ClickHouse and using it in production.
that's often the case, right? Maybe the executive team is not aware of what the engineering team has done, and it's also the beauty of open source, right? Where you don't need permission as an engineer working at a New York City hedge fund. You may not need to ask permission to get ClickHouse running, but you obviously don't have to get the finance team to approve an invoice. So I'm sure that there are a lot of instances of ClickHouse out there that many more than even folks are aware of. What does the rise of the data lake architecture mean for ClickHouse? And how is this influencing the ClickHouse roadmap?
Data lakes look like a data format for the tables disaggregated from the actual query engine. So you can use different query engines on top of the same data, and even share this data between different organizations. So it is quite nice. By the way, recently I have made a prototype that demonstrating that ClickHouse format is also a good data lake. But okay, about
A competitor to Parquet, you're saying that the native ClickHouse's underlying storage implementation itself could be something you could store in an object. You are already storing in object stores, and that's something that could become a standard, much like Parquet or I guess LanceDB is another example of a format out there.
it doesn't have to become as widespread as Iceberg. And the point of ClickHouse is not only about a good data format, a good query engine, but also about integrations. With ClickHouse, you can connect data from like Postgres, MySQL, and Mongo and join everything together. And in the same way, you can read a bunch of Parquet files from S3, Azure, or even Hive.
It's not either or, right? It's both. And that I think there's a question here in terms of architectures that some people think about a data lake architecture as the data will live in the data lake and we will bring the compute engine to run over that data lake. That's one approach. But that's again either or to another approach, which is there will be data in the data lake as a kind of permanent archive of our data, but a subset of that data that we choose to frequently query, we're going to orchestrate into another engine and then in a much more efficient format for querying, and we're going to serve those queries that require higher performance, higher frequency, more efficiency out of that orchestrated subset of data that may live in ClickHouse format.
It should work. It has its use cases, but the question is why don't put everything into ClickHouse?
It's certainly a question that I think the answer probably would, from a data engineering or a VP of engineering perspective, is the same reason why they don't put all of their data in any one tool. I think it's about interoperability. That may change, but that would, I suspect the answer would be the world's not ready to adopt a one size fits all database. But to that point, I'm gonna fast forward and ask about thinking about this landscape. We've got Iceberg, we've got ClickHouse, we've got tools like Trino, we've got the cloud data warehouses. Where do you see ClickHouse fitting in this landscape? If we think about complementarity, where do you think ClickHouse is a complement to another tool, another technology, and where is it a replacement?
First of all, there are underlying fundamental technologies like object storages such as AWS S3 and Minio, and we're definitely not going to replace Minio. We integrate with these technologies. Another area of complementary technologies is streaming engines like Kafka, Redpanda. Actually, I personally don't use Kafka. I just insert data into ClickHouse with the insert statement.
What do you think about object store backed alternatives to Kafka, like WarpStream. Have you come across that company?
Yeah, it sounds very natural. There is some compromise. It is half a second latency on inserts. It is mostly unavoidable. So half a second is like 90% latency when you use WarpStream with object storage. But apparently it is still good enough.
I think the experience I think a lot of people have had with real-time analytics is that, well, first of all, it's an overloaded term. Real-time can mean real-time reads, or it can mean real-time writes.
It should mean both.
It should mean both. I think, but I think the experience of a lot of organizations is that they have, I think, a greater need for real-time reads than they have for real-time writes. And
but don't compromise on this. Don't accept the defeat.
That's great. There's certainly also a cost, right? There's cost trade-offs. I think anyone who thinks about real time versus micro batching versus batching.
Don't think use ClickHouse.
I'd be remiss if I were doing an interview and I didn't bring up the topic that is on everyone's mind these days. You're doing a world tour right now as part of your role here at ClickHouse. San Francisco, I've heard, is the first stop. So in some ways, you're at the epicenter of the AI revolution that's going on and the innovation we're witnessing in the development of large language models in particular. Two questions in terms of how AI can impact ClickHouse, both the technology, the community, and the users. The first is, where, if anything, do you see AI having an impact on ClickHouse's internals? How do you see AI impacting ClickHouse internals now or potentially in the future?
AI is quite a wide term, and we should think about different terms. So machine learning,
yes,
AI, and inside AI there is generative AI, large language models, yes, etc. So let's start with classic old school machine learning, even statistical methods, even Bayesian optimization. And we already use it inside ClickHouse. For example, when we do dynamic dispatch for different CPU instruction sets, and for different computational kernels. For example, AVX 512 could be supported on the CPU, but being actually less efficient than AVX 2. And no one will tell you about this. And we do the following. We start picking a computational kernel at random, collect the statistics, and then use a simple Bayes formula from high school to choose the best one, to start picking the best algorithm more frequently. I would not say that this is AI. Definitely it is not LLM and not a generative AI. But actually, generative AI still makes sense for database development. For example, what about testing the databases, finding corner cases? What about making database accessible for people who don't write SQL? It is a quite popular idea. It is applied many times, and we have this feature in our product in ClickHouse Cloud.
I just want to highlight that what you've just shared is that when people ask, why is ClickHouse so fast? Just to play that back for a second, you are saying that internally in ClickHouse, when a query is run, there's dynamic optimization occurring in terms of the types of instruction sets that are being delivered to the kernel. And is that where does that state live? If I rerun queries again and again, is it part of does it get flushed every time I restart ClickHouse? How does that? I guess the machine learns a better approach. How does ClickHouse, the instance, retain that learning between sessions?
It does not. It lives in memory. On restart, it goes away. And it is very practical. Let me provide one example. So, about caching algorithms, there is LRU, there are 2Q algorithm, there are many. But there is also one very simple algorithm. make a cache of limited size, like 1000 of entries. Put entries into the cache, and when it is full, just erase everything and start from scratch. And it is very practical, it has minimal overhead, it works perfectly, and you can write it not in a minute, in half a minute. And it is very popular when we have to learn from game developers, even from competition programmers. I'm not a competition programmer, but I like to learn from my colleagues who has this experience.
By the way, I've heard it said before that the best algorithm to predict the weather, and Nate Silver, covers politics, he's also apparently a poker player in the United States and a statistician. He wrote a book about prediction, and he said that for a long time, the best weather algorithm for predicting tomorrow's weather was simply take today's weather and replicate it. So the simplest algorithms are often sometimes the best. We're going to move to a question just about a bit more of your background, and I actually didn't initially wasn't going to ask about this, but for those out there, one thing you talked about was in 2009 you thought about creating ClickHouse, and you didn't want to create ClickHouse. You, in fact, you tried to take these other tools and they didn't work, and you were kind of, if you had told someone that's what you're going to do, they probably said you're crazy. Or if someone told you, I have an idea, I want to create a database, you would have told them, that's crazy. What have you found as a creator of this database technology, as a creator of a new tool that's been widely adopted in computer science? What have you found has been the most useful academic subjects that you studied that have relevance to the development of ClickHouse?
I studied mathematics, graduated as a mathematician, and sometimes I like to see connections between different areas. One example is, so let's suppose we have a hash table, and let's suppose it is linear probing hash table. It's like a line, an array. When you insert an item, you calculate a hash. From the hash, you derive the place, put the item there. If the place is occupied, you take nearby place and put it there. The question is, there will be some spans of contiguous occupied places. What are the lengths, distribution of lengths of these spans? And let me give you one answer that is incorrect, and maybe you will explain me why it is incorrect. So, the incorrect answer. It can be modeled with a stochastic process named Chinese restaurant process. Do you know it?
No, I've never heard the Chinese restaurant process.
It's very funny. So imagine a Chinese restaurant and everyone sit at round tables. And a guy came to a restaurant and they look at these tables, and there are different number of people on each of these table. And they will select a table with probability proportional to the existing number of people at each of these tables, plus some other probability to take an empty table. And this process will model distributions such as distributions of cities, city populations, like cities in the United States or in
like a Zipfian distribution.
Yeah, like Pareto distribution. And similar will be for this hash table. We have more probability for this item to expand the existing chain. So it is modeled by a Chinese restaurant process. And now, where is the mistake?
I know we don't have to. No, I'm curious. This is like we will probably edit this, but it seems like it should be, you know, uh, well, yeah, it seems like it should be each time a new item comes in, it's a random. It should be a random location in the hash table that it's mapped to. Now, if that first location it goes to is mapped, it takes an adjacent. So I don't know. I don't see like a Pareto distribution being the right one because it feels like it should still be. I don't know. There's no kind of conglomeration effect that you would have or something.
Yeah, if you have a small fill factor, there will be almost no such an effect. But if the fill factor is 50% or above, then they will combine together. And the mistake is that I explained this for without considering that these chains can also collide with together and merge together.
Ah, right. So the space you had a lot of space between the adjacencies.
Yeah,
At some point, you start to have them combine.
yeah, and the performance of the database will degrade.
Ah, okay. Interesting. Well, then it just depends on the how populated that hash table is then.
Yeah, and there are also
Sparse.
other interesting examples when you don't have apply like high mathematics, but you just have to pay attention to some details. Like you have a tuple of two integers. How to construct a hash table of this tuple? Sorry, hash function.
Is it you treat them as I'm just making stuff up. Treat them as prime numbers and multiply the prime numbers to create a new a single axis that is unique.
Okay, but let me explain. So most I see this mistake in many code bases. They just calculate a hash function from each element of the tuple and XOR them.
Right.
And this is absolutely incorrect.
Right, of course, because it's not. It's actually it's not a right. Isn't it like a two-dimensional? Yeah, it seems like that's
Yeah, if you have a data set with these components identical for some reason, all of them will be mapped to a single item in a hash table, and you will get atrociously bad performance.
so. As I understand it, maybe from and I think I knew this already from when we met in Amsterdam that you had studied mathematics as an undergraduate in your university, and given what you've just shared, it is clear that that background has been quite useful in the design and the architecture of and in building ClickHouse. Of all the different mathematical concepts that you studied, what would you say is the most impactful for database design? If you had to pick one.
Let me think about this question, because it is difficult to take only a single mathematical discipline. All of them are interconnected.
Okay, I'm going to do a follow up and say this. In my experience, and we talked a bit about this, that one concept that seems to come up all the time in computer science, which has deep mathematical roots, is what we were just talking about: hashing functions. I would love to hear in your own words why are hashes so incredibly useful in computer science generally, but in databases specifically.
It is because hashing is a bridge between randomness and determinism. In mathematics, you have probability theory, and you could say that probability theory is about non-determinism. But the fact is that every statement is about some deterministic. Every statement is deterministic. It works with probability distributions. Probability distributions are well defined. I would say it's slightly incorrectly, but I would say functions. These functions are deterministic. You can combine them, analyze, etc. So what about hash functions? You use the methods from probability theory, but also makes everything 100% deterministic. It allows you to make data sketches, make these probabilistic data structures, but at the same time, these probabilistic data structures will give the same answer every time, and hashing is like this single thing that makes it possible.
Mm-hmm. I love probabilistic data structures, and we could talk more about that. But hyperlog being one of those, which I think today are still underused in the analytics community. Maybe that will change if only we can find maybe easier ways to expose these probabilistic data structures, right? Data sketches, hyperlog, and other data types. I'm going to go back to one other topic, and then we're gonna bring it to an end. But we talked about AI. Really amazing to hear you talk about the differences between um, machine learning, generative AI, large language models. One area where large language models have been clearly widely adopted has been in the um, and generative AI has been widely adopted is in the creation of code, namely software development. And as one of the world's top software developers, I, I'm curious: are you using Cursor AI or ChatGPT to write your software code?
Yes, I use ChatGPT, but not for C++. I use it for less favorable, from my standpoint, programming languages such as JavaScript, Python, and it helps. But the problem is, recently I asked ChatGPT to write a code in JavaScript to make signatures for requests to AWS S3. And it made 5 mistakes. And I spent 4 hours to find and correct these mistakes. It will be better if I have written this by myself. Or should I have used whatever, Anthropic or some
Claude.
Claude?
Well, the story some people say is that at the current stage that these uh, AI code partners are like having a junior programmer that you can delegate to. So clearly, the junior programmer that you asked to write this JavaScript, you ultimately have to check his or her work, and it took you 4 hours to check the work. But it's not a senior programmer, so in the languages that you know extremely well, like C++, there's not the same need to go to delegate that to a junior person.
But I would like to. I will be very happy if these generative models will generate production grade code, large projects. I will use it.
Last question, which is really about just the craft of software development, the craft of software engineering. You remain, when I've checked the ClickHouse of course is open source, and we can all look on GitHub and see who's contributing to the project. And every time I've checked, you are there as the most prolific contributor to the code base. How do you stay inspired uh, and creative when working on a long-term, incredibly complex project like ClickHouse? It's been over a decade now. Um, it's been, I guess, since 2009. We're coming up on a 15-year anniversary since you started this journey. Um, and I would observe when I've seen you present that there's a sense of joy that comes through in your talks and presentations and your demos. And I'm just curious, how have you kept that joy and that inspiration for working on ClickHouse alive now after 15 years?
Sometimes I'm thinking about some problem, and I see that I know exactly how I should do it. I want to do it right now at 3 a.m. at on Saturday, and then I just go and do it.
And luckily, your colleagues here in California are, are awake because it's only 5 o'clock, and you can send them a Slack note and say, "What do you think about what I wrote?" Um, well, I certainly have more questions. I could always we could go deeper in a number of directions, but I think I really want to be I'm just honored and thankful that you took the time to speak today as a guest here on the Data Talks on the Rocks. What is an emerging set of interviews we'll be doing with other leaders and founders and technologists. So thank you, Alexey, for joining me. I hope that more folks will be inspired by your work and this discussion today to pursue their own passions in creating world-changing technologies.
Thank you for interviewing.